So now we're going to be getting into equations. We're going to be covering one-step equations, multi-step equations. Then we will kind of build up into inequalities, where instead of being equal to something, it's going to be less than or greater than. Then there's also like compound inequalities, so that one just gives you a more definite range of the upper and lower limit. And then we'll go into quadratic equations. It would seem a little premature to be talking about quadratic equations right now, but we just want to get familiar with like forming it, and then we'll go ahead and then see how quadratic equations become a parabola, which is like this big U, which can go this way, and then this way. And then lastly, we'll be talking about the guess and check method, which we can use into math problems. Sometimes if something takes really long, you can play with the answer choices and then just plug those into the equation to see if the equation or inequality still holds true. When I was really pressed for time, this was honestly my favorite method. Okay, so let's start off with equations. So, equation. Let's see. There we go. Very clear. So it's a mathematical statement, okay? And it means that two expressions, we know what expressions are. Expressions are just a string of different terms put together, and that's an expression. So 7x squared minus 4x plus 4, that would be an expression. Here an equation is two expressions are equal. So for those of you who have seen the movie Ratatouille, like when he bites into like, I believe a piece of cheese, and then like he imagines like this fireworks show, and then he bites into another piece of cheese, and then he sees something else different. And then when he bites into both pieces of cheese and like I believe a strawberry, then he sees something like the combination. That would be like kind of like an equation. Equation would be you're putting two expressions together. So here's an example. So this is an expression, what we have on the left side. Remember how we said expressions can have variables, it can have coefficients and constants. So here we just have constants on this expression, and we're stating that this is equal to the expression on this side, which coincidentally also only has two constants. So really 3 plus 5 is 8, 8 is equal to 8, that is true. However, some equations might ask, is the equation true, yes or no? So what I like to do, if it was like, so this would be 15, this would be 4, this is not true. So you can put the x right here, but we're dealing a lot with x's in math, which could be like a variable or multiplication. So a really nice way I like to do is just to put this. This means not equal to. It's a mathematical symbol. And whenever you're like crossing out or making checklists or you're crossing things out, this feels just very natural to do. So I really recommend doing this. When you find an inequality is not equal, you do the slash. Okay? So we saw equations with just constants. Let's mix in some variables. So we have 10 minus 1 is equal to 3 squared. So 10 10 minus 1 is 9. 3 squared essentially is 3 times 3. So 9 is equal to 9. That is correct. You could just leave it as just the equal sign, but you know, sometimes if you get distracted during an exam, or you just all of a sudden just lose your train of thought, you might forget, oh, did I already scratch it off or not? Did I check it off or not? And I mean, visually, what you have on the left should equal to what's on the right. But the little check mark is just very nice. It keeps track of everything. It's especially like when, if you remember in grade school, when the teachers would like do, like if you had a test questions or a quiz, they'd go check, 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 x, x. You would, I noticed that my grade school teachers, the ones who are very minimal, the ones who would only, depending on their method, there was 2 different methods they would use. Some of them would only check the ones that were right. So if it was wrong, they'd just leave it. So they would only add the correct number. Some would only do an X on the wrong one, and then they would just subtract from like the total of like 100 or 10. If your country uses 10 as the maximum grade compared to the United States, which is more often than not the 100 scale, there was more error, especially when someone would help them out, or they'd be trying to compare grading materials with other teachers in the same grade level, even with the same assignments. They would find it was much harder. It was very difficult to adapt. So especially if you're looking at these videos, you're looking at someone else's videos, you're like looking at maybe Kaplan study material, or even high-set official material. It's just best to do like the method where it combines both checking and then also knowing for sure what is wrong is just X'd out. So these people were only just doing half of the way, trying to be minimalist, but going back and like if there was an error in their grading or error in your mathematical solving, it's just easier to keep track, which is why people who work in warehouses, people who work in Amazon, very important they do the check, 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 and the X's, just making sure everything works together. Okay. But if you still feel comfortable just being very minimal, if that works for you, great. If it doesn't, go by the tried and true method. Okay, so those were still constants, we just added in exponents. Let's do just more constants and just more steps. So here with these expressions, it's very important to simplify, because truly when you simplify, then you will be able to determine are both expressions equal to each other. So what is PEMDAS? Am I gonna distribute by multiplying the 5 this way and then doing this? Or could I do instead So here, PEMDAS is important. I could just go ahead, parentheses, exponent, multiplication. Oh, there's multiplication, but I also have the little parentheses in here. Wonderfully, it's so wonderful how even if I was torn between doing what was inside the parentheses first or doing the multiplication, it's still right. I could do 5 times 3, which ends up being 15, and then I could do 5 times 4 and then add that, which is 20. I would still get 35 is equal to 35, right? Or I could add the 3 and the 4 together, which is 7, and multiply that by the first 5, and that equals 35. So wonderful. Expressions are just very simple. Just simplify. It's just going through the motions, and then just making sure that whenever you're copying down, which is just the number 1 rule in math, make sure that you are copying down correctly. Okay, so let's do some variables. Okay, so this would be an equation because this is an expression. There's a constant, a variable, and then there's another constant. And there's not going to be a numerical value equal to another numerical value. Like before we had 35 is equal to 35, those were 2 constants. Here, we're technically going to be solving for the value of x. And we've done problems where we solved for the value of x before, so this is a little familiar. So we just want to isolate the x variable on just one side by itself on the side of the equal sign. So what do we have to do? This is a positive 4, so we can undo that with a negative 4 or minus 4. It's so fun crossing out numbers or values. So then we're just left with a positive x. 11 minus 4 is 7. Now, do you remember that if this was a minus x, we would have to multiply everything by negative or divide by negative. That way this x was positive, because when we solve for x, we just want x. We don't want a negative x. And it's like when you go to the store and you want a white shirt, you're asking for the white shirt, not the black shirt. All right, let's get rolling. Let's do a little bit more. Okay, so we have 3x is equal to 24. Okay, so here we have a coefficient, we have a variable, and we have a constant. So we have x multiplied by 3. We can divide by 3, and we will end up with an isolated x. Do it on both sides. Remember, very important to do it on both sides, because you have to do it on both sides. Like, think of it as a seesaw. So let's say that there's 4 children on a seesaw. If one child gets off on the seesaw, and we don't get one other child here, what's going to end up happening is the seesaw is going to be unbalanced. It's not going to be an equation anymore. Equation equal. So in order to perform on, if we have to keep everything equal, we got to perform on one side. We have to go ahead and perform it on the other side. Okay, so x, 24 divided by 3 is 8. And that would be our answer. X is equal to 8. You might even see this. So for that, you would add 24. And you're going to ask yourself, well, shouldn't I just divide by 3 first and not the 24? No. If you're isolating a variable, you want to get the furthest thing away from it. So here, it's kind of like they're married. married, and this would be like the brother and sisters or like cousins. So they're kind of further out. So right here we'd have to add the 24 on both sides. So we'd end up with 3x is equal to 24, which is what we get over here. And then we would continue doing this process to isolate the x. So do be very careful when it's equal to 0. Don't go ahead dividing by 3. This is where PEMDAS is very important. If I try to divide by 3 on both sides first, 0 divided by any number except for 0 is equal to 0. So 0 divided by 100 is going to be 0. If I have 0 divided by 5, I end up with 0. So like let's say I have 0 shoes, or like 0 shoes to put in 100 boxes. How many boxes am I going to need? 0, because there's no shoes. I get really excited. Okay, so I'm going to go ahead and erase this, and we'll do one last problem before we dive into a word problem. Okay. So here we have is x minus 5 is equal to -2. Great. Very straightforward. Add the 5, cancel that one out. Add the 5 over here. -2 plus 5. 5 is bigger, so our sum would end up being a positive number, which is going to be a positive 3. Ta-da! I think now would be a great time to ask about like checking our work. So I know where I mentioned like guess and check. It's going to be kind of similar to something we're going to be doing. Here, we're not going to be guessing, we're really going to solve for it, and then making sure that we didn't do an issue or run into a mistake. We can go ahead and plug the value of the variable back into the equation and see if it still holds true. For one of our IT students who's watching, it's the same thing as doing like a hash for a file. It's kind of like when you do an order also on Amazon, and like you get your receipt, what you ordered online, and then what you see on the item, like on the barcode or whatever it says, the numbers have to match. So like let's say they sent you the wrong thing, you could just go ahead and say, hey, I got the wrong thing. Same thing here. You're going to go ahead and reference back to the original. So let's have x. Oh my. Is my board that dirty? Just a moment. Okay. Oh, there was, you can see, it probably just needs to be washed and buffed. Same thing, if at the testing center you have you might have a smaller dry erase board, or maybe like a little laminated board to write on to do your math work. If you run out of space, or depending on the policy of the testing center, some testing centers don't let you erase, go ahead and raise your hand and they'll bring you a new board. You want to keep a clean workspace. I remember with the paper-based exams, they would always add like extra, like they'd have a question here, they'd have another question here, another question here, another question here, and they'd leave a little bit of blank space here. That was on purpose because they knew students would end up running out of space and sometimes would need extra space to carry over. Okay. Maybe I should get a chisel tip instead of this kind of tip. So we're going to solve x minus 23 is equal to 45. So what do you want to do? What do we want to do? We want to isolate the variable. So we're going to add 23 to both sides, cancel that out. X is equal to 68. Woohoo! Now, are we sure? I know this is very straightforward, but just to demonstrate the principle, we're making something very easy. Check our work. We can do check. So we will just plug in. 68 minus 23 is equal to 45. Here is an equation. We're going to see if it's true or not. So we plug it in. 68 minus 23 is indeed 45. So 45 equal to 45 is indeed true. So I can even, like, if I want to be like extra check worthy, I can add another check up here. Knowing not only did I solve, I also check. It's not necessary to do the other check mark over here if you already have the check mark down here. Just whatever makes you feel comfortable. But I really, 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 really implore you to please, please, please do the check. This will make sure that especially when you're dealing with long equations, you might say, I don't have enough time to do the check. Yes, you do. Because when you're solving for an equation, you're having to use your brain. You're having to copy down. You're likely to get distracted, write down something wrong. There's more room for error here. If we do the check, you can just plug in this number and just do it all directly in the line in the calculator, and this won't be making sure you did everything right. Here, like let's say I have like a bunch of complicated things like variables, division, like different things having to distribute to each other. I would just plug it all in very easy into the calculator, check, totally worth it for making sure you're the right answer. I know, like I think when I was taking the STAR, I did piloting for the STAR exam and took the tax for myself. The check really saved my grade a couple of times. Okay, let's do. We've done quite a bit of equations. Let's do let's do two more equations, and they're one step, and then we'll be getting into more aggressive ones. Okay. So here we've been pretty much just dealing with addition, subtraction, multiplication. We haven't quite done undoing division. We all know what the opposite of division is. It's multiplication. But for some of our students who have been like out of school for a while, or just you don't really see math written like this in real life unless you're an accountant or someone who deals a lot with certain business statistics, but even then you might just have a software that does it for you. We just want to be familiar. If we're more used to seeing like mathematical expressions and the way everything looks in math, we're less likely to be intimidated and feel like we just like fell into the matrix or something. So let's say we solve x over 2 is equal to 17. Okay, we have a constant. We have actually a coefficient here. This is also the same as this, right? 1/2 is the same thing as divided by 2, and it's equal to 17. So I could just multiply by 2 on both sides. And you might, for those of you who have been, might ask, well, you multiply the big number by the bottom number. Remember, it's really the same as this, right? 2 over 2 is 1. So this is this, and then the 1/2 is just dropped down. So then when we're multiplying our fractions, if you are very rusty on this, if you're having trouble like with adding and multiplying fractions, go back to the fractions video. There's no shame in like revisiting fractions. Even I have to revisit fractions every now and then. Like when I wasn't teaching this and it had been a while, nothing wrong. That's why the videos exist. So then we just multiply just straight across, right? Straight across. 2 over 2, same thing as 1. If you multiply anything by 1, it's the same thing as itself. So 1 times x is just x. So then x is equal to 34. Okay, I know I'm getting a little sidetracked, but it's just to reinforce some constants, some concepts, especially because we are approaching the end of the course, and some of you might have entered the class later than at the beginning, so you might be cramming a little bit, and reinforcing information when being in a time crunch really helps not forget the old information, because the thing with cramming is that you're trying to shove in so much information, but it hasn't made it to your long-term memory. So if you keep on adding more info, the old stuff is gonna get like pushed out. But by doing like revisiting information, that's gonna help cement things to your long-term memory. So if you're at the point where you're like, Miss, I already know this, great, that's very good. This is a very good sign. It shows that you're more likely to be ready for the exam. Okay, so let's do solve 5x equal to 75. What do I do? Just divide by 5 on both sides. X is equal to 15. Okay, so we want to check. I just realized I didn't check in the last one. Okay, so I have 5 times 15 is equal to 75. Something else that you can do is do this, like, is it equal to this? That helps too, because this is not a true equal sign. This is like law. This is definitely equal. Whereas this one, this is not a genuine equation that's used throughout the mathematical community, but it's very great for keeping track of saying, theoretically, this should be equal to this. Very different than this definitely equals this. Okay, so theoretically, so 5 times 15 is 75. So does 75 equal 75? Yes. Or I could even do the check mark here if I wanted. And then I would bubble in or click. Click. We're no longer in the days of bubbling in. 15 as my answer. Okay. Multi-step. So I'm just going to write PEMDAS on the side, because when you're having involving multiple steps of undoing operations. I was at a loss for words there. These are the operations, parentheses, exponents, multiplication, division, addition, and subtraction. So honestly, if you don't have this already committed to memory, just when you get that little laminated paper or speech of scratch paper you use during the exam, just write it down, pandas, and then just have that to reference every time you do a question. Okay, just gonna grab some water. All right. So, what are our steps? So, solving, that's big enough. Multi-step equations. Okay, so we have solving multi-step equations. Very good. So, we're going to first simplify by combining like terms. We're going to perform and it doesn't necessarily have to be in this order. Like terms might only appear until after you perform an operation. So like let's say I have I can't really combine these like terms yet, even though they both have x to the power of 1, because I still got to do some stuff to it. I still got to do either this or deal inside first. So let's do 3x plus 6 minus x, curly x. This one looks like something from Assassin's Creed, and this one looks more aristocratic. Then I can combine it to 2x plus 6 equal to 10. Ta-da. Oh, and then I can still, I still have to isolate for my x. So minus 6. 2x is equal to 4 divided by 2 on both sides. I get x is equal to 2. Ta-da! There we go. And here, remember, you always will perform what is, or try to undo what's further away. If you've ever dealt like with, if you have long hair, or even dealing with ropes for knots, if you have like a really big knot, like right here, you don't start trying to take away the knot in the middle. You have to like get rid of the knot further away, and then as you get closer, then you attack it. Same thing might not apply for military purposes. Very different, but this is how you would approach it for math, because that is what your exam is on. Very good. And so, let's see, we have 3 more problems we can do. Okay, let's go ahead and do those. I think this video is going to be longer, but I think I'm going to just split up inequalities into just a separate video, just so it's easier. Okay, let's see. Oh, we need this light. Okay. Okay. So, here we go. Let's do another question. So we had already performed that. terms of 6 minus 2 will be the same thing as 4x plus 5 is equal to 25. So perform operations or undo, and then we just do subtract 5 on both sides. We end up with 4x is equal to 20. Now we can divide 4 by both sides, and we end up with x is equal to 5. Ta-da! So here we get 2 steps, because first we had to not only combine like terms, we also undid one set of operations, which was the addition. We undid it by subtracting, and then we also isolated the 4 by removing the coefficient by dividing by 4. So this will be called a multi-step. So now we want to check. We did all this hard work. It only makes sense to check. So we check, and it's always best to just go back to the original equation, because if, like, let's say I just want to go ahead and plug into this simplified version, you might have done something wrong from here to there. You just want to go back all the way to your original, your carbon copy. So we're going to check by doing 6. We're going to plug in 5 where the x should be. 25. So 6 times 5 is 30, plus 5, minus 2 times 5 is 10. Okay. I could just simplify it by doing 30 minus 5, right? Combine the 5 minus 10. 25. 30 minus 5 is 25. Check. So yes, my answer is correct. Okay, let's do another one. And for some of you, you might be able to already be performing distribution mentally, and that's great. That shows that you're exercising your math muscles. So here it says solve -4 times x minus 6 is equal to 2x. So right here, I actually have to perform the operations. I can either do the distributive property, and I'll just go ahead and do that. First, so we're going to have -4x and -4 times a -6. Remember, 2 negatives become a positive. We're going to end up with positive 24, or in this case, plus 24, is equal to 2x. Now, I know whatever we do on one side, we do to the other side. That is correct, but for this is part of the equation. We're just kind of like simplifying it. So we don't have to like recopy and do the -4. Some people might have thought that, and I can see, like, if you think too hard in the exam, you might start adding things. Like if you're like cooking a recipe and you're not sure, or you don't feel very confident, so you start adding things. Just keep it simple. Just follow your training. With math, you don't rise to the occasion as a hero. You fall back on your training. That's why you see a lot of firefighters, EMS personnel, doctors. They typically won't rise to the occasion. They follow their training. They train. That way, because practice makes perfect. All right. So here I see terms on this side and on this side of the equation. What I can do is that I can either move this one over here or this one over here. Because we read English from left to right, I'm going to go ahead and just move things over here. actually here I end up with a negative 6x plus 24 is equal to 0. Then I can subtract that 24 over here. I'm left with negative 6x is equal to negative 24. I can then divide by negative 6 on both sides. And x is equal to 8. Alright. Some of us might just be totally comfortable with like, hey, 8 equal to x is the same thing. You can actually save a little bit more steps by doing that. So let's recopy this. Let's do like another scenario. Or add the 4x this way, just keep everything positive. This is the thing with math. If you practice enough, you can end up having foresight. So 24 is equal to 6x, and I just divide by 6. At the end of the day, you still do the same amount of steps, except that I'm not really dividing by a negative, and I also don't have to deal with swinging this constant to the other side. This is shorter. Now, in the next section, we're going to be talking about inequalities, like where we're talking about like the signs. Remember how we talked about like the crocodile, or maybe like the shark? I was going to want to go for the bigger item. When you're switching things around, it's just like if you switch plates, the shark is going to go to the bigger plate. So if you flip things, you have to flip the shark too. So just keep that in mind in the future for inequalities. That's going to be the next video. Okay. Now, we also have to perform our check. Did all this fancy footwork. We want it to pay off, so we're going to do our check. So negative 4 times 8, 6 is equal to 2 times 8. Okay, so I have negative 4 times 8, same thing as negative 24. Negative 24, and then negative and a negative equal positive. End up with 4 times 6 is 24. I'm sorry, I did something wrong here. See, this is why we do checks. It's going to end up with here's where it's wrong. X is not equal to 8, x is equal to 4. Same thing over here, x was equal to 4. So had I just gone on doing this, because I was just trying to crunch numbers mentally while also like thinking of the next step. If 8 had been an answer choice, I would have had something wrong. But because of this, I found out, wait, this doesn't equal together. I found that I did an error. So now I made an error, I fixed it. Now I gotta make sure it was the proper fix. So I'm gonna go ahead and plug it in to check. 4 minus 6. Alright, so negative 4 times a positive 4 is negative 16. This is a positive. 2. Sorry, it's 24. Is equal to times 4 is 8. So negative 16 plus 24 is 8. 8 is equal to 8 indeed. Okay, so our answer is correct. X is equal to 4. So you might not just be getting like the expression in the problem telling you to solve. It might actually tell you the equation, but like in plain English. And then it's going to tell you have to assume both of them are equal to each other, both expressions, and then solve. So it is with math or word problems. So I'm going to go ahead and erase this just so we have more room. The product of a number and 6 is 44 more than twice the number. So here, because this is a number, it means pretty much any number that's a variable, because that variable is also going to be the same thing as this variable. I do want to note this for our non-dominant English speakers. A number and then the number. Here I'm talking about any number that exists. And then here I'm talking about twice the number. So here, number, I was talking about any number on the number line, any number that exists. But, I need to apply it to irrational for those of you who are a little more advanced. But then here I'm talking about the exact same number used over here. So truly, just to make it easier, you can understand it as twice the same number. Okay, so the product of a number and 6. So 6 times the number, and we know the number is x. We're going to put x because it's our favorite variable. Is, okay, so this is keyword for an equal sign. 44 more, more. So when you more, it's when you're adding something. So it's addition. More than twice, so twice means you're multiplying by 2, the same number. Yep. So now if you want to solve for x, like if it says, what is the number? Well, okay, so let's divide by 6. Oops, we can't divide by 6 because we have x on both sides. Swing over this x over here. Make my 2 look nicer. If you have messy handwriting, I've met people who have very messy handwriting and they can't understand their own handwriting, especially because you're like 2s, 7s, and even their 1s might all look kind of the same. Just take it easy. Just try to write a little bit neater, or try to distinguish your numbers more obviously. I know with math, when I'm trying to do math on my own, calculations or even budgets, mine's a little bit more messy scrawl. But when you're solving for an answer, do try to be more careful. Okay, so we have 4x is equal to just 44. Now we're going to isolate the x by dividing by 4 on both sides. X is equal to 11. Right, so let's do our check, because we are prone to human error. So we have 6, right? So we can go back to our formula, but maybe we were wrong when we were making this formula. We can go back to the original. The product of a number and 6, so 6 times the number, means equal sign, 44 more than twice the same number. Okay, so we just plug in 11 here. 66 is equal to 44 plus 22. 66 is indeed equal to 66. Yay! So we are correct. Okay, so now we're going to go over 3 more examples, and now it's going to be just equations in word problems. So let's go ahead and erase. Okay. There are twice as many cats as dogs at the pet shelter. If there are 24 pets, how many of them are cats? Okay, so there are twice as many cats as dogs at the pet shelter. So here we want to express the numbers in the problem as the same variable. So we're going to also let x represent the number of dogs, and since there are twice as many cats as dogs, we're going to let that represent x. That actually just makes our lives much easier, because we know there's twice as many cats as dogs. So twice as many cats, right? So this is cats. Oh my goodness, it doesn't even look like an x. As dogs. Dogs are equal to x and cats are equal to 2x, right? Cats and dogs. So if there's 24, that means we're adding cats and dogs. So cats plus dogs equals total number of pets. We're going to add the 2x x is indeed horrible no matter how many times I try to use it. It's equal to 24. I can combine like terms here and end up with 3x is equal to 24 divided by 3 on both sides. X is equal to 8. So I'm not done yet. So here you might want to just circle instead of box. I'm looking for 2x. Cats. Cats are equal to 2 times 8. So how many of them are cats? We have 16 cats. How do I want to double check? 2 times 8 plus 8 is equal to 24. So 16 plus 8 is indeed 24. Everything did come out right. You might see an answer choice that says 8. That is not the right answer. It's asking how many of them are cats. You have to plug in. This is where people they get too ahead of themselves. They might just go ahead with this one. But if you're super smart, you will reread the question and essay. What are they looking for? Okay, so this one's more of a background knowledge problem, but we'll still do it anyway because it talks about consecutive numbers, and that would, if you are not an English native speaker, consecutive in Spanish, another one would, the translation would be seguido. If you're waiting for me to say it in another language, my German's not at the professional level yet, so I can't give you that translation yet. Okay, so consecutive means, like, let's say I have 1, 2, 3, 4, 5, 6, 7, 8. So consecutive means what's next in the order. So the consecutive number would be 1, 2, 3 if I'm following a counting order. But let's say I'm only talking about even numbers. So a consecutive even number, so these are consecutive. Now, if I'm talking about consecutive odd numbers, remember, odd are the ones that don't divide nicely into 2. So if I have an odd number of shoes, it means I'm missing a shoe. So 1, 3, 5, and so on. If I'm talking about consecutive even numbers, even, it means it's a lovely pair, like shoes go together, or socks, is 2, 4, 6, 8, and so on. Just a little bit of background knowledge, because we're going to be using this vocabulary word in our next problem. So you could say consecutive. Okay, so the sum of three consecutive numbers is 105. What is the greatest? it's going to be pretty much, let's look at this visually. If you remember that question with the pipe being cut into pieces, so let's say that all of this is a length of 105. And I'm not going to talk about units because this is just hypothetical. This is just to help us think. So it says that there's 3 parts, and they're not equal because each part is 1 unit bigger. So it would be like x, unknown, and then x plus x plus 1, and then this one would be x plus 2. Now, I'm going to go with consecutive because 1 plus 2 plus 3. It goes on. I'm not talking about even or odd. I'm just going what's consecutive. And it's talking about the sum, so if I put them all together, this will equal 105. Now, some of you may be wondering, Miss, why was it not x plus 1, x plus 2, x plus 3? You have to start off from something. You have to start off from 0 here. This is x, this is one value, and then we add 1 to this. So this is the original. Then we add one more unit of measurement, so we add another number. And then just make this one just a smidge bigger, and it does not look drawn to scale. Let me make it look just a smidgerine better. Smidgerine is not an English term, by the way, for our ESL speakers. So my equation really is x plus 1 plus x plus 2 is equal to 105. Great! What I can do is just combine like terms. So I have x, so I get 3x, right? And I'm going to go ahead and combine the like terms, which are the other like terms, which are these 2 constants. So the 1 and the 2 is equal to 3, and all of this is equal to 105. Okay, so I'm going to go ahead and remove what's furthest away from my variable that I'm solving for. I'm going to subtract by 3 on both sides. Great, so I have 3x is equal to 102. If I divide by 3 on both sides, I find out x is equal to 34. However, this is not my final answer. That's the shortest one, but it's talking about the greatest of the 3 numbers. So the greatest, so longest piece is x plus 2, which is the same thing as x plus 2 is 34 plus 2. So they're saying that this piece is 36. So let's, we see this, but we can always just go back and check by doing 34 plus 35 plus 36 is equal to 105. We go ahead and plug that all in. We do find out it is indeed equal to 105. Okay. Okay, let's go ahead and erase. And we'll do our last problem for this video. Okay. So here in this problem, we're going to be using the difference between numbers to write our equations. So let's say that a play, the ticket prices 200 tickets were sold. If the total revenue means how much money they got. Revenue earned that night was $2,240. Then how many adult tickets were sold that night? Question mark. Alright. So we know what's the price of the child and the adult ticket. We know that 200 tickets were sold. We just don't know how many of each. And then out of the money earned from all those tickets sold, it was $2,240. So we're gonna let X represent the number of adult tickets because that's what we're looking after. I could base it off of the number of tickets for children and then like try to work my way backwards, but you know what, when you're setting the equation, it's up to you and you want to make it as straightforward as possible. It's like when you're building a house or you're buying clothing. You're not going to buy clothing the wrong size and then try to like alter and fit it, although some people do that. It's just more sensible to get something that fits right off the bat if it's available. And it is available because you can make it available. Okay, so we're going to let X represent adult tickets. So X is going to represent the number of adult tickets. So we're going to let X is going to be 200 minus X, right? Where did you get this from? Well, there's 200 total tickets, right? And if we remove the adult tickets from those 200 tickets, we get the children tickets. Okay, and if we would add all of this together, really, X plus 200 minus X is 200. Yeah, it's indeed 200 because this X and this X is going to cancel out. So really this equation does hold true. Okay, so let's set up our equation for solving this, talking about the number of tickets. This is just like the logic behind using these variables and setting up the variables like this. Okay. So what we're going to do is going to multiply each term by the cost for that type of ticket, and then we're going to equal the cost, the total amount of revenue. So I have 12x, so like I have $12 for each ticket, for each adult ticket times the number of adult tickets. And then if I add that to 200 minus x, that's actually going to have to be $8 multiplied by the number of children's tickets, which is 200 minus x. All of that is going to be equal to $2,240. Right? If you get the price multiplied by the number, and then the price multiplied by the number, you get your total sales. So let's kind of like just simplify this and then try to isolate the x. Excuse me. So So we have 12x plus 8 times 200 is going to be 1600 or 1600. The reason they call it 1600 is because it's 16 times 100. It's more common for people to say 1600 in layman's terms, but some people prefer to say 1600. I've seen where people have accidentally meant to say like 1600 when they meant 16,000, but if you say 1600, you're being more precise. Either way is fine. I use both in my own conversations, so one is not better than the other. So we have 12x plus 1600 minus 8x. Alright, now we got like terms. So this is a like term and this is a like term. 12 minus 8 is the same thing as 4x plus 1600 is equal to 2240. Okay, subtract that on both sides. I end up with 4x is equal to 640. Alright, I ran out of room here, so I'm just gonna like write this over here. Divide by 4 on both sides. X is equal to 160. And that is my final answer because X is equal to the number of tickets. Question is asking for a number of adult tickets. If I want to check, I just go ahead and say 160. Plus 200 minus 160 is equal to 200. I know that if I subtract 200 from 160, I get 40 tickets for children, and that will still add up. There you go. That is it for equations. We will be seeing them later on with graphing, but that's going to be just for another video. Okay, see you next time.